Sadhji, can you please repeat again this rated voltage sequence again?
Rated?
Operating sequence.
Yes, sir. Rated operating sequence is, see, the breaker. Now, if I enable the auto reclosure function, the breaker, what is happening? Let's talk in this way, in application point of view. I am having three phases in the transmission line, R, Y, and B. Suppose if a fault occurred on the R phase, this is just a temporary fault. It's just a temporary fault. So I have done the survey and I felt that as per IEEE, I forgot where I read that, but it is a statement that 80 to 90% of the faults in the transmission line are transient faults. A 5 to 8% or 10% are only the permanent faults. So I should not, for the transient faults, like an example that a tree branch is hitting to this conductor and going. So when it's hitting, it acts like a LG fault, line to ground. So what my relay censored that it is a fault. It is a fault. So my relay sent the command to the breaker. So breaker operated. The breaker operated. That is the operation mode. But I am thinking that is a transient fault. So I am giving a breaker one more chance that I will close you. You please see if this fault still exists. If still remains, then I will operate all other two phases also. I'm giving an option to that. So for that, the auto reclosure, some conditions to be satisfied, that I will talk in the control and protection class. So there should be some time that is generally 0.3 seconds. So after 0.3 seconds, I am forcefully closing the breaker with an assumption that the fault is a transient fault. But if my guess is right, well, good. So again, the breaker closed, again the operation is going on. Suppose my assumption was wrong. I made a wrong assumption. So what will happen? The breaker again, the relay again still seeing the fault. It will send the command to the breaker. No, it's a permanent fault. Please open. Instantaneously, it is opening. And at the same time, it is operating other two phases also, YB, with the concept of pole discrepancy. There is a change in poles. Pole here means phases. One phase is open, one phase is not open. So three phases are unbalanced. One is open, other two are not open. So there is a pole discrepancy. So based on the pole discrepancy concept, the breakers will operate the other two phases also. So the breaker is opened. So now let's see, the breaker opened twice. So the breaker opened twice means the moving contact moving away from this fixed contact. This is a fixed contact. This is a moving contact. Moving contact is moving away from this. So there is an arc formation. This arc is quenched by the SF6 gas surrounded there. So how many times? 2 times. If it done 2 times, then the SF6 gas which is present here get ionized. So now again, if you are closing the breaker, suppose if you close the breaker again, if you close the breaker and if a fault occurred there open, the breaker will blast because it's not able to quench that arc because no sufficient dielectric strength. So we give some time to that breaker. That is 3 minutes as per IECs or as per IEC standards. 3 minutes. Then after that, you can close the breaker. And again, the operation repeats. Clear?
Yes. Thank you.
Yeah. So, others team?
Mr. Santosh, actually, regarding this opening and closing, regarding the short circuit, what is the DC component?
Yes.
I couldn't get that.
Yes. Come to the DC component. Generally, in the in the substations, in the transmission network, we won't much focus or concentrate on the DC component, because the transmission lines, see, substations or a transmission is nothing but a transmission network which is coupling the two substations. Means the power is pooling to here, and from here it is moving out. So the DC component is not much effect here. But if you go to the generator circuit breakers, if you check the, if you see the generator circuit breakers technical specification, there they will mention a specific DC component there. How much the DC component means short circuit, additional short circuit it is adding. So in the generators, near to the generators, generally the generator circuit breakers which are placed near to the generators experience this DC component. So for those breakers, again, we have to mention that my short circuit current, suppose 33 kV is my generator. So my short circuit current is not 25 kA. 25 kA plus the DC component. How much DC component depends upon the X by R ratio of the subtransient and the subtransient reactance X by on the resistance of the generators. So system, so the X by R of the system, we will consider that. We will show here that. So this is the DC component. So additionally, I required, suppose 25 kV. Additionally on this, I required one more 10 kA for DC component to break or to make, whatever it may be. So in the normal substations, these breakers will not experience this DC component. Only the generator breakers which are nearer to this will get experienced it.
Okay, that is fine. Thank you.
Yeah. So others, any doubts? Okay. So let's go to the schematic drawing team.